Hello, and this video is an attempt to explain the notion of a plan, or otherwise known as a floor plan. A floor plan is in fact an orthographic projection, which is actually a horizontal cut through a three-dimensional object. In this case, we're using a cube that was part of the assignment for Design 1, in which you were to create a stereoatomic mass and through the deductive process of sculpting, peel away from that mass moments that would create some spatial complexities. And then what we'll do is we'll take that mass and we will create our plan from it by creating a horizontal section cut. Now, in theory, you're using a physical model that you're drawing a plan from. So your horizontal section cut will in fact be an implied or an imaginary horizontal section cut. And then you'll translate the line work or the geometries from that section into a scaled drawing. I don't have the physical model to measure from or cut from, so I'm going to use a digital analog using the SketchUp model that we've created together to show you how to create the plan drawing, how to measure it, and then how to recreate that drawing in a scaled form. Now, I will be using Autodesk Revit as a drawing component just to show you how to do the line work, to measure and draw the line work. You'll be using pencil and paper, and so the process is very much the same, just the input device is different. So hopefully you benefit from this video, and let me know if you have questions in the comments below. All right, so moving on to this is the model that I've created as an analog to your physical model. And as you can see, it has a variety of deformations to the shape. So it is different on every side, but this is in 3 dimensions, and it is still an orthographic projection, so it is a scalable drawing as opposed to a perspective. And so I'm going to show you now how to draw the section, which is in fact the plane, the plan cut. So you do this a couple different ways, but if you were to search and type in section, you'll get several options in this particular software, but the one we're going to use is this hotkey S. So we're going to turn that on, and then we're going to use section plane. And notice that right now it's already set up to be a plan section cut. So I'm just going to come up to the top of this model and click that moment. And using the move tool, if you're doing this in SketchUp, just move that line down to what seems to be an appropriate section line. I prefer plan cuts. Well, in real life, if you're drawing a plan of a building, these horizontal lines, horizontal sections that become plans, are in fact somewhere between 30 to 40 inches above the ground plan or the level line that you're dealing with. So in this case, this is a 24-foot model. So we're going to come down to about a third, which is about 16 feet below the top, which is 24 feet. So it's roughly an 8-foot section cut. Okay, so that's in generally what a plan is a horizontal section cut. And now I need to look at it from the top down, right? So I'm going to choose, in this particular way of doing it, the plan. And then I'm going to make sure that we're still in parallel projection, not perspective, right? So I'm looking at orthogonal line work. The stuff in black is the stuff being cut through. So it's and when you do this, you're going to do the same thing, but instead of black, you're going to use yellow in the form of trace paper. You can do black if you want, but it's a lot of black, and it's the saturation will be hard to pull off, I think. Well, we'll see. But anyway, so what now that we have the model cut, and again, you're not physically cutting your model, you're just going to draw an imaginary line at that plane, the cut plane, and then you're going to measure those elements and draw that and plan. So for me, I have this. I'm going to dimension it or measure it so that I can recreate the drawing in Autodesk. Sorry, Revit. So I'm choosing the dimension tool, and I'm going to pick just the larger dimensions just to get started with. And I'm not looking for 1/16 of an inch accuracy. I'm just looking for some overall numbers. So in this case, 17 feet 10 is going to be just fine for me. I'm going to choose another dimension, which is this guy. And then I'm just trying to get every dimension that changes the location of line work, right? So I think I got most of the perimeter. I'm going to do this one. I'm going to do this one. This one. And then these two are probably the same because they're parallel. Well, not probably, they are the same. So I think I have all the dimensions I need. So now I'm going to go into, now this is where once you've dimensioned everything or measured in your world, then I'm going to go to, you would take this to your piece of paper and redraw these. So I'm going to use my digital paper, which is Autodesk Revit, and I'm going to draw it at a 1:1 scale. Let's see, I have to create a 1:1 scale. 1:1. 1 inch equals 1 inch. Perfect. Okay, so using the annotate tool for here, I'm going to create a line, and my first line that I'm going to recreate is this one, this top line, which is 19 feet 11. That's so close, I'm going to make it 20 feet. So click once, and if I'm drawing with a pencil and paper, I'm just going to put one point and then draw my line out, and then later on I'll measure it to be 20 feet. So 20 feet, okay? And then I'm going to go back to my measurements, and now I know I have to turn down 90 degrees, 8 feet, okay? So I'm going to click my second point, come down 8 feet, enter. And then I know if I go back to my drawing, and you'll have these as two separate drawings, right? So if I go back to my drawing, you will, and you'll have this one up here. You will notice that all of my turns, they should be anyway, 90 degrees. So that makes life a little easier. So this one is 4 feet. So again, I'm ignoring the 1/16 of an inch accuracy. I don't need to worry about that. I'm going to come down vertically again, another 8 feet. So 8 feet. I'm going to come in, so I turn 90 degrees again. This time 6'1" 5/8. So that's close enough that I'm going to get the 6'1". Okay, so I'm going to do 6 feet 1, enter, and then come back down, turn again 90 degrees, and I think it's another 8 feet. Okay, so that's the complete top right sides. Now I'm going to come across the bottom, 17 feet 10. 17 feet 10, right? And then I'm going to come up. Ooh, I didn't get that measurement. Darn. Okay, so now I'm here. I'm going to come back and get this measurement because I realized I missed one. So I need this one. I could do the math maybe, but I'm just going to simply measure it while I'm here. Okay, so I'm going to come up 14 feet 6. So back here, 14 feet 6. It's good enough. I'm going to turn in, so a right turn again, 90 degrees, 13 feet 5. 13 feet 5. Okay, I'm going to come back up 6 feet 10. Okay, oh, wait, I have to be in the right program. 16 feet 10, enter, and then, something's not right. Let's go back. 6 feet 10. Okay, so click 6 feet 10. All right, that was my mistake. And then come back over 13 feet 5 again. 13 feet 5. and should be a simple close, 2 feet 7 11 7 16ths. I'm going to round up 2 feet 8. Boom. Right. So this is what we've done. We've taken the physical model, or in your case a physical model, in my case a digital model. We created a horizontal section cut, and now we've traced that section cut, or we've measured that section cut so that we understand where the line work falls in relationship to the model. So that's the physical product, and this is drawn at 1:1. So if I were to measure this, it should be, well, you can't really see it because the scale is so bad, but it should be 19 feet 11, right? So you want to check yourself and make sure 19 feet 11 that your measurements add up. So that's good. So we've done the right thing. So now that's if you're drawing 1:1. Okay. You guys, per your requirement, or your drawing assignment was to draw at 1/4 inch scale. So even though this is 1:1, in real life, you're drawing at 1/4 inch equals a foot. So you have to divide that 1911 by 4 to get your actual, the length of space you're drawing. But since you're using an architectural scale, you just use the 1/4 inch scale. Matter of fact, let me grab one of those real quick and I'll show you what I mean. Okay, so if you have one of these, this is an architectural scale, and you'll notice that they're broken up into different measurements, right? So there's 1/2 inch, and then the regular, sorry, not regular, but 3/32. Is it better that way? Which way is better? This way. Okay, 3/32, 1.5 inch, 1/8 inch, right? 1/8 inch, and again, right? So, and then this is one end. If you flip this around, again, there's 3/4 inch. There's the normal ruler, 3/16 down here, and 1/4 inch down there. So that's the one you're actually going to be drawing in. So when I say 19 feet 11, you're going to come all the way over here to 19 feet, right? And then the 11 will be one of these little tick marks here. So that's how you're going to draw. You're going to measure your drawing using the architectural scale. And I did provide a link in Canvas for you to how to use this and how to draw that. So it's a separate video. But for our purposes, again, you're back to you've measured your model, you've recreated that drawing in pencil on trace paper or vellum, whichever you had, and so now you have your plan drawing. Now this is everything at the cut plane, right? So the cut plane represents the line at its thickest. So in my world, I'm going to show you through exaggeration in graphics what you should be what weight you should be using for this guy. So see how thick that line is? That represents a cut plane. That's a line thickness of the plane you're being cut at. And if you watch the other video that I gave you as part of this assignment, where it talks about the line weights, the different types of graphite and the weights that they represent, this would be your soft 4B or 2B or something like that. And then if you remember in our model, in this particular view, there's actually a little piece here that I'm not cutting through, which means it's below the cut plane. That's a new line weight. So I'm going to measure that real quick, and we're going to draw it. So that's 1'6" in length. I'm sorry, width, 8 feet. Actually, I already knew the 8 feet. So come back here, and we're going to use annotate again, but I'm going to change my pencil from a 4B or 2B to like a 2H. So I'm going to use a thin line, right? It's a thin line. And so it's going to come over 1'6", I think is what we said, and then down 8 feet. And hopefully what you see is the line weight difference between those two things. Again, the thing being cut through is thicker, meaning it's closer to the viewer, and the thing beyond is lighter. So that creates depth in a plan. Well, I hope this was helpful. This is really all you need to do for the plan drawing. Oh, actually, that's not true. Let me back up. I've also asked you to create a graphic scale. So I'm going to show you that real quick too. So let's go back to desktop. And a graphic scale is just a way that helps people understand what size this drawing actually is. So I'm going to get rid of some of these things just so that we can focus only on the drawing. So a graphic scale, again, is simple representation of size. And since we're drawing it 1-to-1, we'll do this but we know that the scale we intend to draw is at 1/4 inch. So we're going to draw these things in units of 4, right? So the first block, and the thickness of the thing doesn't matter, it's the length that matters. So the first block should be a minimum of 4 feet, right? And so what I do is I start out with a 4-foot block, and then I multiply that times 2 generally. So that's an 8-foot block, and then I draw it up again, and then that's a 16-foot block. Oops, I guess I didn't do something right. 16 feet, 16 feet, right? So I'm trying to show that there's different increments. So this is with text. I'm going to show at a very large scale. Well, let's see. I have to bring up my properties again. Sorry for that. 1 second. Not that one. This one. Okay. So this is 1/4 inch text. I'm going to make it, because again, I'm drawing at scale, I'm going to make it 1 foot text. Text size 1 feet. There we go. So I'm going to start at 0, right? And then I'm going to draw another one. That'll be 4 feet. Whoops. And draw another one. That's at, let's see, 4 feet plus 8 feet is 12 feet. And then 12 feet plus 16 feet is 28 feet. Right? So 0 to 4, that's 4. This is 2 blocks, 2 of these, so that's 8. So 4 plus 8 is 12. And this is 4 blocks, or 16 feet. So 16 plus 12 is 28. So that's a graphic scale. Okay, so I'm asking all of you to produce a graphic scale on your plan so that whoever you give this drawing to, so I'm asking you to produce this graphic scale. So whoever you give this drawing to with this graphic scale, they'll be able to create their own measurement tool, measure your drawing, and with fidelity be able to recreate it or build from it. So that's what I've asked you guys to do. We would have done this live in class, but the last assignment didn't go as planned. So I'm creating this short video to help you with that bit. So hopefully this was helpful, and we will see you in class. Take care.